3 kilogram block.
Alright. Alright, so we got mass. The block equals 3.00 kilograms.
Starts from rest at top of a 30-degree incline.
Stop. Theta is going to equal 30 degrees.
I believe it's 30.0, correct?
30.0. Yep.
And slides 2.00 meters down the incline.
So stop, the change in the parallel direction will be 2.00 meters.
Okay, so what I'm going to call that is delta D parallel. It's not the displacement in the x direction or the y direction. You said it very well. It's the displacement in the parallel direction. So I usually put delta D parallel to illustrate that. It's the displacement in the parallel direction. Good.
Down the incline in 1.50 seconds.
Then the change in time is just going to be 1.50 seconds. Over. Oh yeah.
Oh, find the coefficient of kinetic friction between the block and the incline.
Alright, so we're trying to find the mu k. Yeah.
There are two important pieces of information that are missing from the translation here. Who can give me one of these?
Between block and the incline.
I'm going to, those are the only two objects really, so I would assume that that's correct. Andrew?
So it started from what? Rest?
So velocity initial and the parallel direction is going to be equal to 0. The other one is a little more subtle. I think it's important to know that it slides down the incline. So if we have our picture, it helps us to figure out the direction of the force of kinetic friction if we know which direction it's moving. So we have the object is right here, and we can get our free body diagram. Jessica, please give me the free body diagram.
Force of gravity is going down.
Now that we have broken the force of gravity into its components and we have the equations for those, we can actually start with the components of the force of gravity.
So force of gravity perpendicular is going perpendicular to the surface.
Perpendicular and down.
Yeah. Force of gravity parallel is going to this way, left, and it's parallel to the surface.
Okay.
Force of kinetic friction is going to the right and parallel to the surface. And force normal is going perpendicular to the surface.
Great. So there is our free body diagram. I do want to take a moment and just talk about the force of gravity and the direction. Yes, Connor?
Really quick, isn't the displacement in the parallel direction going to be negative?
Why is the displacement in the parallel direction negative? Wicked.
Because it's like moving down to the left.
It's going down into the left, which we've defined as negative. Great. So this is an important piece that often gets neglected. The displacement in the parallel direction is down the incline, which is negative. And
What if you drew the incline in the other?
then it wouldn't be. Then it would be positive. But then when you sum the forces, it would match when you sum the forces. Okay. The force of gravity, class, is always in what direction? We'll try that again. Class, the force of gravity is always down. Now, for some reason, when I bring up the force of gravity parallel and perpendicular, every once in a while I get a student who tries to draw the force of gravity parallel up the incline. Does that make any sense? The force of gravity parallel is always down the incline. So please remember that. The force of thank you, Knickerbocker. That is silly. But trust me, it will happen every once in a while. You look at that and be like, I think it should be up the incline. But realize force of gravity and up really very rarely go together in the same sentence. So the force of gravity parallel is going to be always down the incline. Okay, we have force normal, force of gravity perpendicular, force of gravity parallel, force of kinetic friction. We are set. We've drawn our free body diagram. We don't have anything to break into components. We can do our next step. Leah, what would you like to do?
Some of the forces in the parallel, some of the forces in
Pick one.
parallel.
All right, we'll start with the parallel direction. Go ahead.
Force of kinetic friction minus force of gravity in the parallel equals mass times acceleration in the parallel direction.
Great. Force of kinetic friction minus force of gravity parallel equals mass times acceleration in the parallel direction. Good. What can we do now, Gerben?
We can calculate acceleration.
Sure. How are we going to calculate the acceleration?
Well, PF change in d in the parallel direction
True.
is -2.0, so you can use the UAM equation. Change in d in the parallel equals velocity initial in the parallel times change in t plus 1/2 acceleration in the parallel times change in t squared.
Great. So now we have all of this information. We can figure out the acceleration in the parallel direction. We have -2 equals initial velocity, which is 0, plus 1/2 times the acceleration in the parallel direction, which we're solving for, times delta t, 1.5 quantity squared. We multiply both sides by 2. We get 2 times -2 equals 1.5 squared times the acceleration in the parallel direction. Therefore, the acceleration in the parallel direction equals 2 times -2 divided by 1.5 squared. The acceleration in the parallel direction, please. -1.7 repeating meters per second squared. Okay, we now have the acceleration coming back to the equation. Christina, what now? Looking at this equation, what can we do with it? There's more we can do with this before we move on to some of the forces in the perpendicular direction. I agree that's something we're going to need to do, but let's do more with this. How that helps out?
You know the equation for the force of gravity in the parallel direction, which is mass times sine theta.
Don't confuse the magic trick. Magic trick. I tried to sequester the magic trick.
Sorry, G.
Cordoned it off.
Mass times G is sine theta.
Clear delineation for the magic trick.
Yeah, I just grabbed G.
All right, so now what about the force of kinetic friction? David, what can we do with that?
Are we going to sum forces again?
We are. We are. Don't you worry. We will do that, but I want to make sure we get to the point where we know why we're going to sum the forces. Kyle.
UK times force normal.
We have the equation for the force of kinetic friction is UK times force normal. So what is it about this equation that says we have to stop now and switch to the other direction? Kosa.
There's two variables that we don't know.
They are?
UK and force normal.
We do not know the force normal, we don't know the coefficient of kinetic friction. Clearly, we're solving for the coefficient of kinetic friction, so we need to figure out the force normal. And
isn't force normal equal to mass times g?
I'm glad you asked that question. He just asked, isn't the force normal equal to mass times the acceleration due to gravity? Josh?
It's equal to.
No, I don't want to know what it's equal to. He asked the question, is it equal to mass times the acceleration due to gravity? It's a yes or no question. It's a yes or no question that you are not going to answer with yes or no. You're going to answer with the question, I don't know, because I have yet to sum the forces in the perpendicular direction. Because you don't know until you sum the forces. Yes, the answer is no in the long run, but realize, yes, I said the answer is no. Leah, look at me like that. Remember, if you're trying to figure out the force normal, you have to sum the forces. You can't just say it's equal to anything. You have to actually figure it out. So let's actually now move on to summing the forces in the perpendicular direction. Please sum the forces in the perpendicular direction. Steph? Yep.
Okay, force normal, which is positive, and force of gravity, perpendicular, which is negative, equals maximum acceleration in the perpendicular direction.
Okay. Great. What is the acceleration in the perpendicular direction of this block that is sliding down the incline? Andrew?
Can you repeat the question?
Yes. What is the acceleration in the perpendicular direction for this block that is sliding down the incline? Notice it's not moving in the perpendicular direction. So the acceleration in the perpendicular direction is equal to 0. So let's return back to trying to, if we were instead to sum the forces in the x and the y direction, can you identify that the acceleration in the x direction as it slides down the incline is not going to be equal to 0? Right? That's not going to be equal to 0. And the acceleration in the y direction as it goes down the incline is not going to be equal to 0 either. So it would be very complicated to sum the forces in the x and the y direction because neither of those would be equal to 0. When we sum the forces in the perpendicular direction, the acceleration in the perpendicular direction equals 0. Therefore, we get to the force normal minus the force of gravity perpendicular equals 0. So the force normal equals the force of gravity perpendicular, which equals, what's the equation for the force of gravity perpendicular? Please? mg cosine theta. Class, do we know the mass of the object?
Yes.
Let's try that again. Class, do we know the mass of the object?
Yes.
Do we know the acceleration due to gravity here on planet Earth?
Yes.
Do we know theta?
Yes.
Do we have a numbers dependency?
Yes.
Yes, you do. I am not going to stoke your numbers dependency. There's no reason to plug in numbers at this point. Why? Why would we do that? Why would we plug in numbers?
Because you're just going to have to.
There's no reason to plug in numbers. What are we going to do with this force normal equals mg cosine theta, Leah?
Plug it into the first.
We're going to plug it back into the equation we abandoned earlier. And we now have uk times mg cosine theta minus mg sine theta equals mass times acceleration in the parallel direction. David? I'm afraid I don't think I understand that. Headler? No, I still don't understand. Sorry, I'm not fully understanding this. Knickerbocker?
Everyone brought mass to the party.
That's right, ladies and gentlemen, people. Everyone brought mass to the party. We can be equitable. We can take mass from everyone. Therefore, we get uk times g times the cosine of theta minus g times the sine of theta equals the acceleration in the parallel direction. We know the acceleration in the parallel direction. We know everything with the exception of uk. Let us solve from uk. I'm going to move down here to keep so I have a little bit more space. So we have bringing g sine theta over to the other side. We get uk times g times the cosine of theta is equal to the acceleration in the parallel direction plus g sine theta. Dividing both sides by g cosine theta, we get the coefficient of kinetic friction is equal to the acceleration in the parallel direction plus g sine theta, all of that divided by g cosine theta. The acceleration in the parallel direction is negative 1.7 repeating, plus g, which is 9.8, times the sine of our angle, which was 30 degrees, divided by 9.8 times the cosine of 30 degrees.
So it'll be 6, 7,
0.368 is the coefficient of kinetic friction. And I do want to reiterate that a standard mistake is to forget that the displacement down in the parallel direction was down the incline, which when we sum the forces we said was negative. So please make sure that you have the displacement direction match. Class. Anything new today? Just a little bit. The force of gravity parallel and force of gravity perpendicular, right? New, not new. The force of gravity parallel and perpendicular, but please identify that other than that, it's all stuff we've been doing before. Bless you.